The CRISP-DM method is a cross-industry standard process for data mining. It's a structured, thorough, and validated approach to data mining. It consists of 6 different steps in order to get through the process. First being data understanding. Determine the business objectives and goals to allow you to tailor your data mining projects to support them. You'll assess available resources and requirements and risks, determine data mining goals, and produce a project plan. Next is understanding the data. You'll gather the data, check for quality issues, describe and explore it, and verify it. Next was data preparation. You'll get the data ready for analysis, select any data that you would want to work with, clean it, construct it, integrate multiple data sets together, and format the data. You'll document everything about the project and data, highlighting data patterns and characteristics. Next step is modeling. You'll select the best modeling technique and which algorithms would best be used, and generate a test design, build a model, and assess the model results. Next is evaluation. Does the model meet the business goals? Review the process to see if anything was overlooked and determine what the next steps for the model will be. And after everything is all wrapped up, comes deployment. You'll deploy the model and monitor it, and at the end produce a final report. A time series analysis requires time as an independent variable to understand the data at hand. Analysts record data points at consistent intervals over a set period of time rather than just recording the data points intermittently or randomly. Time is a crucial variable because it shows how the data adjusts over the course of the data points as well as the final results. It provides an additional source of information and a set order of dependencies between the data. Time series analysis typically require a large number of data points to ensure consistency and reliability. An extensive data set ensures you have a representative sample size and that analysis can cut through any noisy data. The principles of data ethics include 4 different points: privacy, transparency, accountability, and equality. In privacy, even if an individual provides their information to a company, that does not mean that they want it to be used publicly. To protect the identity, data should be in a secure data set. Data may need to be anonymized in ways such as differential privacy, which injects noise into quantitative data associated with customers to the point that they cannot be identified. Additionally, a dataset can be de-identified by removing any personal information about the customer. In transparency, individuals should have an overview of the data that is collected, stored, along with how it is used and how it is shared. Accountability. An organization is responsible for data that they collect. They must safeguard it at all costs. And equality must be a company must be careful not to disadvantage and discriminate against individuals and groups when they are handling the data. In order for companies to uphold these principles, they should require consent to share personal data, anonymize data, be clear what data they do share, and safeguard the information of their customers and not discriminate or disadvantage against any individual or group. In the case where I'm an analyst at a financial company and have concerns about the bias in the way a predictive model is measured, I would first address this to my manager by providing examples within the data of how it is biased and how it may be disadvantaging specific groups. Once we have an understanding of who or what is being specifically biased, we can go about re-evaluating the models, or if it specifically is concerned with the validator who was initially part of setting up the model, we may have to adjust who is evaluating or create a standard set of goals in which the validators will follow to see how the data falls into it. In ways to avoid this measurement bias, multiple measurement devices could be used. You could design communicative testing procedures clearly and openly. And as I said previously, make sure the validators have an adequate level of experience and training and a consistent testing process, and review and update scoring evaluation processes. Lastly, what's the difference between a regression and a classification model? A regression model measures relationships between qualitative variables and uses real values. It's usually used to create a predictive model to see how one variable may affect another variable and make that prediction. A classification model, on the other hand, predicts what category an entity will fall into based on a set of predefined features. It helps to separate into categorical classes or discrete values. So regressions work with strict numbers and classifications work with categories.